Okay, so on Wednesday, we had the first test. And I just want to remind you that the lowest test score will be dropped. I did notice there was a few people that didn't make it to the test, and so that's fortunate for them because there's no makeups. So I wanted you to keep that in mind and just go forward. The other thing is, the last time I taught this course, this exact course, it was 3 days a week. It was Monday, Wednesday, and Friday. So I'm contemplating having Friday as a tutoring session, probably at the same time. Now, if that appeals to you, send me a message in XYZ. But think about it, because I think we probably could use a little bit more airtime to work through things. It wouldn't be required at all. It would just be optional, but it might appeal to somebody. So let me know about that. And in the meanwhile, what we have, let's see. So this was this problem, but we'll get there. So 3.3, oh, this is what I want to do first. Some people just lose it with fractions. And this was something I made for a student a while ago. So it's add, subtract, multiply, divide. So the adding and subtracting requires the common denominator. And so if you're going to add or subtract, you need like things. And so that's what amounts to getting a common denominator. But remember, in you multiply and divide, you can multiply or divide anything. So the only difference is with multiplication, you make sure you have simple fractions, not mixed numbers. And so then you cancel if you can, and then multiply across. The only difference with division is once you have nice little fractions, simple fractions, not mixed numbers, then this second number gets inverted. And then you just treat it like multiplication. So that's the overview of this chapter. So I don't want you to feel confused about fractions, because adding and subtracting are completely different than multiply and divide. And so I see people trying to get common denominators for these two things, and that's not good. But anyway, what I want to do is quickly talk to you about 3.3. And this is fractions again, but the only difference is we're adding and subtracting mixed numbers. So this is not a big deal. Oh, this is a sweet one. Let me see. This was 2/3. This would have been better. Let me change that. That's 2/3. And so what we see is we're going to add them. The denominators do not match. And so we have to get a common denominator. So I'm going to go 3 and 2/3, 4 and 1/5. I'm going to try to figure out exactly what the common denominator needs to be. So with a 3 and a 5, I think you can probably figure out 15 would do it. I don't think that's a big deal. 3 and 5, 15. So in the first case, you have to multiply by 5. So 3 times 5 is 15. 2 times 5 is 10. Okay, so really the 3 and the 4 that's here, really we're kind of ignoring it for the time being. The 1/5, to get it into 15 requires a factor of 3. So 5 times 3 is 15, and 1 times 3 is 3. So now we have a problem. We're supposed to add, we need common denominators. We now have them. So the big part, of course, is not adding these two. That's easy. It's adding these two. So 10 and 3 make 13 over 15. And then this is 7. Okay. When this is done, you make sure that this fraction is reduced. And of course, this one is. So we're good. So there's one thing that might happen, and let me see. Let me just make up a problem similar to this. Okay, this is good. So the common denominator is easily 10. And so we can turn this into, what we need to do is bring this up to 10. So this is going to be 2 and something over 10. This is going to be 1. And because it's already in tens, we can just copy it. We've decided 10 would do it. We went to the larger one. A larger one was big enough for both of them. And so now we're going to multiply by 2 in this one. So 5 times 2 is 10. 3 times 2 is 6. So the reason this one is slightly different is 6 and 10 make 15 over 10, and 3 and 1 is 3. Now, if you turn that answer in, chances are they'll mark it wrong. And the reason is, there's 2 reasons actually. 15 over 10 reduces. But 15 over 10 is an improper fraction. So think of this like money. Somebody's saying, well, I've got $3 and change. You know what I mean? Well, wait a minute. 15 over 10, thinking of this as money, is more than $1. It's more than 1, isn't it? Because this number is higher than that. And so it really is more than 3. It's over 4. Somebody raised their hand. Go ahead and talk.
Hi. I have, are you just reviewing the homework, or are we gonna take a test?
We'll have to talk individually about the test. And I can deal with the homework as well. Maybe we could do that at the end of class.
I gotta go. I have work.
Send me a message then.
All right, thank you.
Exactly what you need, okay? So here we go, 15 divided by 10. Remember, we could reduce that by 5 if you wanted to reduce it now. So 5 goes into 15 3 times, 5 goes into 10 2 times. So we've improved it, but it's not ready. This 3 divided by 2 is actually 1 1/2. So 3 divided by 2, it's 1 left over, 1/2. So what we actually have is this much, 3 plus 1 1/2. So the answer they're looking for is this. 3 and 1 is 4, 4 1/2. So why did this require extra steps? 2 reasons. The fraction we had wasn't reduced. And this was an improper fraction along with a whole number. And so 3/2 became 1 1/2. So now we're into 4 1/2. So this is just trying to give the fair answer. It's back to money, which most people deal with. $3 and change. No, it's really $4 and change. You see what I'm saying? The more accurate version is $4 and change. So they want to hear it the simplest way and the clearest way. And so that would be that. Any questions about what I just did? Okay. So the other thing that comes up that might be annoying has to do with borrowing. And so you remember borrowing in all kinds of cases, decimals and so on, whole numbers, borrowing. But in this particular case, I picked a problem that had the common denominator, so we didn't have to fuss with that. But when we would go to subtract, 1 take away 3, no. And so what we're going to do, we have to borrow. So in terms of money, if you can relate to money, if you had to make change, you'd have to turn this 8 into 7 and change. And so this is taught several ways, but one student actually, can you see that this is not big enough to subtract 3? So you end up borrowing 1 from the 8. But what happens is then it's 7, and then it's plus 1 1/4. So the one that I borrowed came over here to the fraction part. Okay, so I haven't thrown any money away here. But at this point in time, this was the cuteness of it. Remember how you would make that a mixed number? 4 times 1 is 4 and 1 is 5. So what this actually became, and this is the extra step, 7, whoops, let me try it. 7 and 4 and 1 is 5. 4 and 4, 4 times 1 is 4 and 1 is 5. That would be that. Subtract 3 3/4. So I took 1 off of the 8, I put it over with the fraction part, I made an improper fraction. This will now subtract. 5 take away 3 is 2/4. 7 take away 3 is 4. And you'd think after all of that, you're done, but you're always looking right here. Does this reduce? And if it does, that's your job. And so they always want the simplest answer. They usually say so, but honest to goodness, if they didn't say so, you'd have to do it anyway. I'm sure they say so, but sometimes you don't read. So this is divide by 2, this is divide by 2. So this is 4. 2 divided by 2 is 1. 4 divided by 2 is 2. There's the final answer. That required borrowing. Did you like it? They taught it a different way. And I'm going to show you the other way, just in case you're into that. When you realize you're in trouble because there's not enough to subtract 3, they would borrow, and then they would add 4/4, because that's the common denominator for borrowing 1. So then this became 7 5/4. But I've found that somehow students, they lost it right here. I think the other way, some students showed it to me, and I thought, well, wait a minute, that's so clever. Because you can clearly see we took 1 away from here, but we put it over here. And then we made an improper fraction. I think it's easier to recall, but I could be wrong, but it was new to me. I'd never seen it in a book, but I thought it was useful. And so anyway, this is the way it has typically been taught. Okay. All right. All right. I'm going to go to 3.4. And if we have time, we'll practice some more. This is bringing in exponents and then doing multiple problems, which will include the one that we had from the beginning. If you have parentheses and you have a square on the outside, that means that both numbers are squared. So what that really means is it's 5, 6 multiplied by 5, 6. I think that makes perfect sense. The parentheses are saying, I want 5, 6 twice. You look to see if it cancels, but it won't. So all you can do is multiply across. This would be 25 over 36, because this did not cancel. This does not cancel. And so that problem is completely done. Interesting enough, here's another one that's slightly different. 1/2 times 3/4 squared, okay? This 1/2 here is considered multiply. There's nothing there. But this part here is the power. And so this is ignored, and you do the 3/4 times 3/4. Okay, so we've taken care of the exponent. Now we can deal with 1/2. And you look to see, because anything from the top be canceled with anything from the bottom, and all you have are 3s up here, so there's no 3s here. So you have no choice but just multiply across. But I wanted you to see that what I dealt with was the exponent first because of order of operation. Then I brought in the 1/2, and now 3 times 3 is 9. And I'm going to do this backwards. 4 times 4 is 16, times 2 is 32. I'm not going to fuss about thinking this needs to be reduced because it didn't reduce here. So I say done. Okay. This one, sometimes people have trouble with the distributive property. And so here's an example in this section. Now, technically, you could combine these first. Because it's 1/2 and 2/3, you need a common denominator. But I'm thinking, well, wait a minute, maybe I don't have to do that. And here's the alternate way. This is using the distributive property. And so here we go. This is 12 times 1/2 plus 12 times 2/3. Now notice how I wrote the 12 high, because I'm going to put it 12 over 1 in both cases. Now I could see what was going to happen, and that's why I distributed. Do you see what happens with the 2 and the 12? They cancel. 2 goes into 2 once, 2 into 12, 6, and 6 times 1 is 6. 3 goes into 12 as also. This really worked out. 3 into 3, 1, 3 into 12, 4. 4 times 2 is 8, over 1 is 8. Look at that messy fraction business turned into whole numbers, and there's your answer. So the distributive property actually helped us. And so don't be afraid to use it if you need to. Now, let's see if I can find it. Well, here was a problem from this section. And so it has to do with order of operation. Now notice this number times this number is multiplied. This times this is multiplied. And adding is dead last. So you might as well do the front part and the back part and then see if they'll go together. Now, that means you could basically ignore this part for the time being and deal with it and deal with here. Now, remember, with multiplication, you could multiply anything by anything. But the trouble with this is it's a mixed number, and so you make it a simple fraction. 5 times 2 is 10, plus 4 is 14 over 5. We might as well finish this, and notice the 4 and the 14 would reduce right now, and I want to reduce it now before the numbers get too big. They both divide by 2. The 3 and the 5 isn't going anywhere, but the 4 and the 14. So 4 divided by 2 is 2. Divide by 2 is 7. So I divided both by 2. And so now I'm going to multiply across. 3 times 7 is 21. 2 times 5 is 10. I'm going to leave this for the time being and see what happens over in the other problem. Well, when I look at this, I'm going to ignore the front part, the part I just finished, and focus over here. Is that clear? So I see several things that annoy the heck out of me. First, I will put the plus sign down. 2/4. 2/4 is really 1/2. So that's annoying me. And so I could actually turn that 2/4 into 1/2 right now without hurting the problem one little bit. That's the first thing that annoyed me. The second thing that annoyed me was this. 4 divided by 4 is actually 1. So this is 4 plus 1. This is 1, this is 4. 4 and 1 is 5. So that this simplified, and this was a heck of a mess, and simplified down to the simple little 5. Now I still have to do this. And so 5 becomes, notice how I write it high, becomes 5/2. 1 times 5 is 5. 2 times 1 is 2. This is not done, but the hard part is completed. So now, because these don't have a common denominator, I'm going to rewrite this vertically, and it's 21/10 plus 5/2. I do not have to make this a mixed number. I can just leave it like this. And the common denominator, you look at the largest one, and the largest is 10. So 10 will work for both of them. I'm going to write 10 in both cases. This would be 21. And so 2 wants to go into 10. I need a factor of 5, and it's 5/5. 2 times 5 is 10. 5 times 5 is 25. I'm now in a position to add them. And I have 21 and 25 is 45/10. 45, I'm sorry, it's 46. Boy, I'm slow. 46. Still, it still needs reducing. I was thinking about that. And so bottom line is they're both even. Therefore, I could divide them both by 2. 2 into 46 is 23. 2 and 3. 2 into this is 5. Now, at this point in time, you have to look at your instructions. We have a pretty good answer. It's an improper fraction, and sometimes XYZ will take it. If they said they want a mixed number, no questions asked, then you have to give them the mixed number. So let's say they said, give us a mixed number because we don't want that. But remember, in some cases, we actually entered it this way and the other way, and they both marked it right. So it's 23 divided by 5. 5 into 23 goes 4 times. 4 times 5 is 20, 3 left over. So this would be 4 3/5, which is the correct answer. And I have no idea why they didn't mark you right. No idea at all. Unless the instructions said they wanted, I don't know what they wanted. Or the most common error of all errors is copying the problem wrong. That is the most common error. So there's a rule for pharmacists, okay, that when they give out a medicine, they check it 3 times. I don't know if this is true, but I've heard it. So when you're copying a problem, be sure to check it at least 1 more time to make sure it's copied correctly, because that is the most common error. Besides doing the problems wrong, copying leads the pack. So if for any reason this was copied incorrectly from the book, that would be, this correctly went to 4 3/5, which is what you had. So the only thing I can think of is either XYZ is having a hiccup, or It was a copy error.
It's XYZ for sure, because I
Okay.
put that total in, and I just reread the question again, and it says to simplify. It doesn't say to leave it as a mixed fraction.
Yeah, and so chances are that, I mean, assuming that the programming is correct,
Mhm.
then if they don't force you to do one thing, go for the easy version, which would have been this one. Saves a step. Okay, how's that? So that's basically what you're interested in. You have to keep in mind. So can you tell me the order of operation? Remember, it was 1, 2, 3, 4. Order. Order of operations. Do you know this by heart? If you don't, you should put it, write it on paper and tape it to your wall.
Are you talking about multiply?
Yeah, what's
divide.
first? Can anybody put this together for us? Because this is going to be so important as we move along.
Multiply, divide,
Multiply,
add
divide
and
down
subtract.
here.
Do parentheses first, grouping syllables first.
Parentheses.
Oh, okay.
Parentheses is first, and then anything inside the parentheses that needs doing. Does anybody recall what number 2 was? I've locked, my thing is stopped. What's number 2?
The exponents.
The exponents, exactly right. Number 3,
Multiplication.
multiply or divide.
Divide.
See what it's freezing on me. It's probably the wind, who knows? Left to right, if they're both back to back. So divide could be done before multiplication if it's on the left. And then last is add, subtract, dead last, left to right, if there's any doubt. So this, please excuse my dear Aunt Sally, was the old one. PEMDAS was another way to remember it. But the thing with that is it looks like multiply is somehow better than divide, and they're equal, okay? And so my thing is freezing on me. I see some chats. I didn't see what they said. Let me go back. Let me kill this. Guess you can't go halfway. Oh, good. All right. I saw some chats. If somebody wants to turn on their mic and tell me what it was about. But I think depending, some people have, they've learned this in the past, but it didn't click, or there was some little part of it that didn't work. The only way to beat this is to get in there and do that homework, practice, so that you get past this, because this is totally doable, but you can't be an observer. You have to get in there and do it. And I know sometimes I see students are not attending class, they're not getting their homework done. This is the quickest way to not make it. Okay. So I think 3.5 complex fractions is not included. I want you to see, let's see if I can make, it's with a fraction on top and a crazy fraction on bottom. That is not covered, so we'll just let that go. What I'd like to do is keep this in mind, because this applies to everything. I want to most people have better luck with decimals. But remember the page about, I did it before. To add or subtract, you must have like things. Here's how it applies to decimals. So if I have 14.1 plus 0.28, I have to line these things up so that I'm adding whole numbers, the ones place to the ones, the tens place, the tenths place, and so on. I have to put things in perfect order to add or subtract, or I'll get it wrong. And it's based on this rule. So I'll do that problem in a minute, but what I want to do with decimals, okay. So if this was money, you would know what to call it. This is the first thing they ask you to do is take, this is 25. And the word "and" only appears at the decimal point. This is the tenths. T-E-N-T-H, that's what makes it different, the TH. This place is the hundredth. TH. So this is tens place. This is tenth. And this is hundredths, and the next one would be thousands. So this would be big red, 25 and 12. And you tell the place that that last number's in. This is 12 hundredths. And if you forget the TH, you're going to be marked wrong because that's the only difference there. So let's try this one, 3. My lovely computer. Tenths, hundredths, and the 7 is in the thousands. So this would be read 3 and 7 thousandths. N for the decimal point, and 7 is 3 places over, so it's thousands. So back to this problem, which was, I did it a minute ago. I'm going back and forth. I have to line them up. So this is 14 and 1/10. This is 0.28. Notice neatness counts here. I mean, not too much, but enough so that we have to do it. Notice the decimals line up. And most of you probably don't remember this, or although maybe you do. Here's a junk book. They would put the line here to separate out the whole numbers from the cents, because they wanted you to line this up so that you added properly. Now, I use a calculator, I'll tell you that right now, but that line right here was meant to separate out the whole numbers from the decimal numbers, because people used to do things by hand. So here we are. Sometimes people would put a 0 here just to have things lined up. You didn't have to, but you could. So if this was addition, this would be 0 and 8 is 8. 1 and 2 is 3. There's my decimal point, and then this is 14. Any question? Is that makes sense, doesn't it? Adding. Subtracting would be the exact same thing. You better line it up or it's not going to work. Now, if, for instance, they wanted this as a mixed number, the way to write it as a mixed number is to know how to say it. And to say it, it's 14 and 38 hundredths. So the hundredths basically turns it, the decimal, 0.38, 38 over 100. So if you wrote it like this, then the minute you go to fractions, they're always assuming that you will reduce it. And so if that was the case, this would have to be reduced because both of them are even. So 2 goes into 38 19 times. 2 goes into 150 times. And so that would be the answer they would like if that was what they asked you to do. Okay. Now, there we go. If they ask, if they start with the problem in words, notice 55 is hyphenated like they've done in the past because it's a 2-digit number. But when we see hundredths with a TH, we know we're on the decimal side. And so there was no end. It was not like 3n something. This is all on the decimal side. So to do hundredths, you have to go over 2 decimal places. Tenths, hundredths. Can you fit 55 in there? Yes, you can, 55. On the other hand, if you have 55 thousandths, THS, again, tenths, hundredths, thousandths. The 55 doesn't start here. It has to back up to here. And so it would have to go there. Well, I don't have a number here. What would you say? What makes sense? Anybody?
0.
0, correct. So notice when it was hundredths, I had to put in 2 numbers and I had 55, so I dropped them in. When I had thousandths, I have to have 3 decimal places and the number 55 had to back up, be over here. And so that was that. Now I had one more thought. The 0. I can't always see all of you because a lot of you are behind a screen and I can't see you, but I assume you're younger than I am. It was very common at one point in time when you have decimal point 45 or 45 hundredths to leave it like that and assume that was the correct answer. But 30 years ago, they tried to bring the metric system into this country. It was sort of a dismal failure, but they tried. At that point in time, they started including that front 0. Maybe it was 40 years ago. I don't know. It was a ridiculous amount of time. But they brought it in. And so this became standard. So it's just like an English class where there's a standard way to do things like the footnotes, there's a standard way. In math, this is now standard. But I see things like this on road signs. So you can tell somebody is, let's call them old school, that's how they learned it. This is now the standard way to write things. And so the hospitals were the first to adopt metric system for medicines and everything this zero became critical. And I've been told by nursing students or even people working in a hospital that when they're writing up a report, this is required. In other words, if it's not in there, there could be a penalty. The hospital can be fined because it almost like here, it's like, did you forget to write the number in? They want things perfect. So there's no question about what's what. And so the front zero here, although it doesn't change the value, is critical. So this is now standard. Do I occasionally write a problem without it? Yes, based on the fact that that's how I learned it. But in the end, it should be included. And I think most of you have been taught that one place or the other, and it has to do with your age. Is that okay? So, the thing about adding and subtracting, remember, to add or subtract, you must have like things. So in decimals, that means the decimal point for adding and subtracting must be lined up so that you're adding tenths to tenths, hundredths to hundredths, the ones to the ones, the tens to the tens, and so on. But if you remember the second half of this rule, you can multiply or divide anything by anything. This is the rule. I write it like this because I think it's critical. That means that if I have 1.5 multiplied by 0.23, this is in tenths, this is in hundredths, but I don't have to line them up or anything to get it right. Okay? So this is what I'm going to do. I'm going to multiply it just like it's 15 times 23. So 3 times 5 is 15, carry a 1. 3 times 1 is 3 and 1 is 4. So that's what I got when I multiplied 3 by 15, 45. Then I take the 2. And remember, in the 2, I only have to move this over because this is going to be adding. 2 times 5, 10, carry a 1. 2 times 1 is 2 and 1 is 3. So 2 times 15 is 30. So I do this the exact same way I would have multiplied these two. The 3 times this, the 2 times that, and now I bring this all down. But wait a minute, I've got the decimals. And so in order to make this decimal correct, I count. I have 1 for this one. I have 2 for that number, which is a total of 3. So starting from the same side, I go 1, 2, 3. That's where the decimal belongs. So this was 1 decimal place. This was 2. The result when we multiplied is 3. Is this my final answer? 345 thousandths, TH? Well, if we were paying attention to that 0 thing, I would put the 0 in. And I don't know, XYZ may not penalize you for doing it, but if you're in a science class, if you ever have to take a science class, they will dock you every time you forget. That could be hundreds of times in a science class. Every single time you'd lose points. So it's better just to get with the program and start putting that. I call it the decoration 0. Nobody else says that. It doesn't actually change the value, but it's now considered standard. And so that's what I want you to do. Tell me, Has anybody gone ahead? Is there any of these problems you'd like to see more of? The multiply, the add, the subtract? Or do you want me to just find one and have you, and let's do it? Anybody have something? I got one for you. Most of the time, when you have multiplication of decimals, you have to put it out, do it like this. And do it out and all. But the truth of the matter is, when you see multiply by 10 or 100 or 1,000, life is good. And this is partly the reason that the metric system is 10 times better than this fraction system we use. And of course, if you're from somewhere else, you're used to the metric system. And but in this country, we've been really slow to get on board. This, when you multiply by 10, shifts the decimal point one place to the right, making it larger. This is 27.5, 27 5/10. And so you don't have to fuss, you don't have to waste good time. And I don't want you to waste good time. I want you to realize this is the case. Let me try another one. If you multiply a decimal number by 1,000, it's a shift of 3 decimal places. So I'm going to write this number down and I'm going to shift it 3 places. 1, 2, 3. Well, wait a minute, I didn't have a number here. I have to put a number in because that's where the decimal belongs. And I had to put in a 0. So this is 1150. The decimal is here. But in general, the best answer is the simplest. These are things, the more you do math, the more you realize there's certain rules that nobody ever says, but they all kind of go with it. This is simpler than that. And so this is better. Okay, did you see what I did? I saw it was 1,000. This is only works with 10, 100, 1,000. I saw it was 1,000. I moved it 1, 2, 3. And because I didn't have a number there, just to slip around, I had to insert the 0. You can do it out the long way, but I don't recommend it. I recommend taking advantage of this cute little thing. So if it was 100, that's a 2 decimal shift, making it larger because multiplying by 100 makes it larger. So 1, 2. Answer is 120. And it's so much safer to do things like this, and so on. They have a few in the homework where you multiply by 10 or 100 or 1,000. And so when you see that, go for it. Let's do something. Okay, decimals, decimals, decimals. Order of operation says parentheses first. This problem is begging you to think of money so that you'll just relate. This is 2 cents and this is 3 cents. Is that okay with you? So this is 5 cents. Well, that took care of that. But now it's this and this. The assumption is multiplying. I'm going to line it up. The only multiplication is the 5 times 5 is 25. And 0 times whatever doesn't really do us any good. But the decimal point needs to be corrected. And so notice there were 2 decimal places in the first number that we multiplied and 2 in the second. That's a total of 4. So you start here and you move over 4. 1, 2, 3, 4. Notice I had no number here or here, so I have to insert decimal point 0025. So this is tenths, hundredths, thousandths, 10,000ths. So this would be 25 10,000ths TH. Are we perfect yet? We're not perfect yet. What do we want?
A 0.
Good job. A 0. How's that? Okay. So this is combining, you had to use order of operation, but that's okay. We were all set with that. In general, people have better luck with decimals, although I've seen students having just as much trouble with decimals as fractions. But I do think in general, they're easier to work with. You don't have to get that common denominator thing. And this is partially the reason that metric system works easier for people. This is why the hospitals in this country were the first to switch over to the metric system, because it's easier and they do not want to make any mistakes. You get it? Yeah. Okay. Anything? So is there any particular, I still have a few minutes. I could do division as well. I don't know. Let me just make up a problem. Oh, I wrote it, but it didn't fly. Let me see what people have said. Okay. All right. I'm going to do a few, and we'll clearly need to work some more on this, but this is 20 divided into 52.5. If this is a whole number without a decimal in it, you can immediately bring this decimal point straight up and start to divide. So 20 divided into 52 goes twice. 2 times 20 is 40. We will subtract and get 12, and I will bring down the 5. Because 12 is smaller than 20, I made the right choice. So 20 into 125, 6. 6 times 20 is 120. And I'll subtract. Now, they may give you some problems where if you would continue to divide out, it would end up with 0 remaining. I think this will do it. So I'm going to continue. We're going to have to look at instructions. I'm going to add a 0. I can see this is going to eventually divide out. 20 into 50 goes twice. 2 times 20 is 40. 10 left over. Aha, I'm going to add one more 0 and get 100. I could see this coming. 20 divided into 100 goes 5 times. 5 times 20 is 100. Remainder 0. This is what's called a terminating decimal. In other words, if you had the strength to continue on, you would get one exact answer with a 0 remainder. Two and 625 thousandths th.
You called it a terminating what?
Terminating decimal. In
Yeah.
other words, if you divide it would terminate sooner or later. And so that's the termination. There's no point in going any further when you have a 0 remaining. Terminating. Uh-huh. Do you know why I mentioned terminating where it stops? Do you know why I mentioned some problems stop?
Some of them infinite.
Some of them go on forever. This one will, because this is a whole number, I can bring my decimal up, but let's do one of those. How's our time going? 3 into 20 goes 6. 6 times 3 is 18. When you subtract, you get 20, a 2 rather. Uh-huh. See, we're going to keep going. 3 into 20 goes 6. 6 times 3 is 18. How far do you have to go before you say, oh my gosh, I'm in a loop here, right? And so this 6 will go on forever. Well, certain numbers create this. This is called a repeating decimal. And it doesn't stop. And so when you have a repeating decimal, you've got to find a way to stop because you can't finish it. There's no finish to it. And so one thing they might do is say round it off to a certain number of decimal places, and you could do that. The other way mathematically is there was a 6 in front, then a decimal, but the decimal continued to repeat. And it would, I don't know how many times you have to do that before you say it's going to be a 6. This is a repeating bar. And so that's telling us it just keeps repeating. So they may or may not ask you to do that, but you might as well see it now because that happens. Certain numbers that you divide by create repeating decimals every time. And anything, any kind of a 3, 3, 6, 9, anything with a 3 in it will do that. There's other ones that repeat. Actually, the number 7 repeat when you divide by 7, but it goes out. When you divide by 7, it goes into a loop. And it's like 6 digits long, and then it goes into a loop. Most people don't divide far enough to see it. But what I want to do, I want to do one more. Well, this is different. This dividing with a number that has a decimal in it needs to be corrected. And so what we will do is move this over 2 places. This is the same thing as multiplying by 100. 1, 2. But you can't multiply one number by 100 and ignore this. So fair is fair. Multiply this one by 100, multiply this one by 100. Okay, I multiply by 100 because it took 2 places to clear it, to make it a whole number. The decimal was assumed to be here. I've got to do the same exact thing here. So this got multiplied by 100, and so did this. This decimal now comes straight up there. Now, it depends on the person, but some people can't take a mess. And so if you can't take a mess, then rewrite it clean. Well, did I make a nice problem or what? 125 into 250 goes twice. 2 times 125 is 250. Well, when I get a zero remainder, I'm done basically, except for the fact that the decimal is here. And then I need a number here. And that's why I brought that decimal up, to see that, wait a minute, something's missing. 125 into 0 is 0. And so the answer is actually 20. If you ever if you're not sure, you can check it by 125 by 20. This would be 0, this would be 0, carry a 1. This would be 5, this would be 2. Is 2,500. I've double checked this, but that is correct. I moved these over 2. I brought my decimal up. I didn't have a number there. And so the decimal point was here. I needed a number to hold that place. It's actually a 20. And so just be careful about that. So if the number you're dividing by has a decimal in it, you've got to shift it that many places and do the exact same number of places over here. Any question about that one? Do you remember all this? See, everybody has pieces because somebody taught them. And so the question is, can we bring it back? Were you taught this or not? That's what I'm interested in. And can you get it? Can you find a way to get them right now if you didn't get them right before? That's what we're interested in. Okay. So we can move on and take another course if needed. Okay. Any question? Tell you what, I'm going to stop